Hi guys, welcome to the Kitchen Think, a place where we share with you our ideas, our thoughts, our conversations about recent scientific discoveries in the field of medicine, health, and fitness. In today's video, we're sticking with the topics of the COVID-19 pandemic and COVID-19 vaccines. More specifically, we want to address some of the questions that we got from you, our viewers, in regards to the new variant of the SARS-CoV-2 virus. So that's the topic for today. Are you ready? Let's get started. Before we dive into the details of the different variants of SARS-CoV-2, we need to backtrack just a little bit. Viruses in general, like SARS-CoV-2, they can't live in isolation. They actually need a host to be able to survive or to live. So usually when they enter a host, a living organism like an animal or a human being, what they'll do is then infect certain cells in our body. And when they do so, they hijack what we call the proliferation machinery in the cell. And they do this in order to make a lot of copies of itself. So multiply and proliferate by using the cell's machinery. In the process of doing this, not only do they make copies of themselves, but they can also lead to negative ill effects on the host, on the human. Hence the symptoms of the disease and potentially death, like happens in certain individuals with COVID-19. So that's in general the idea of viruses, how they live and how they how they survive, if you will. Now, during the process of making many copies of itself, during the process of proliferation, the virus can make inaccuracies or mutations. Now, these mutations are extremely common in viruses, especially RNA viruses like SARS-CoV-2. To give you an idea, about 6 months into the pandemic, about September of 2020, the scientific community had identified over 10,000 mutations in the SARS-CoV-2 virus that was moving around the world compared to the original virus. So extremely common, these mutations. Now, specifically with SARS-CoV-2, what's interesting is that it actually, the rate at which it creates these inaccuracies, these mutations, is much lower than other viruses. So about a third of the rate at which, for example, the HIV virus creates or makes these inaccuracies, these mutations, and about half of the rate of what the influenza or the flu virus would do. So again, super common for mutations to occur. And because of that, the scientific community is constantly monitoring the appearance of mutations in the world. Now, what do mutations do? Honestly, most mutations have absolutely no effect, no interest whatsoever in the context of the virus. But some mutations, and by the way, some of the mutations can usually occur, most of the time the mutations occur in a group, meaning there's a group of mutations that happen together in what we call the cluster. So some of the mutations can actually also have a detrimental effect on the virus. For example, many years ago, when researchers were investigating SARS virus, so sort of cousins of SARS-CoV-2, they identified some mutations that actually rendered the virus, the specific virus, and not as able to infect hosts, to infect humans. So that's a detrimental effect on the virus. The other thing that the mutations can do, it actually have a positive effect on the virus. And when they have a positive effect on virus, they usually have a negative effect on the host, on us, on humans. What kind of positive effects can the mutants or the mutations have on the virus, on SARS-CoV-2? Well, it can increase their ability to the transmissibility, the ability to infect people. And therefore, you would see a lot more people infected with that specific strain. As a direct effect of infecting more people, there would be more deaths associated with that specific strain of the virus compared to the original strain. So that's another thing that can happen. Another thing that the mutations could cause is a way for the virus to evade the therapies, more specifically the vaccines that are built to combat or to fight COVID-19. And that's where most of your questions came from. So we will address them. Out of the many mutations and variants that have been identified, there are two that have been hitting the headlines a lot and two that you are obviously interested in. One of them is a variant that was identified in the UK around December of 2020. And one of them is a variant that was identified in South Africa also a little bit later, but also in December of 2020. So let's talk about those ones in more detail. So the reason why these two variants have been of interest to the scientific community is because the epidemiology studies have shown that these two variants, the mutations in these two variants, have caused the virus to be more transmissible, meaning it can infect more people and spread throughout the community potentially faster. So the next question that the research community wanted to answer is whether the vaccines that are being developed, that have been developed to combat the spread of SARS-CoV-2 and COVID-19, whether those vaccines would protect us not just against the original version of the virus, but also these strains of the virus. Now, before we get into the detail of what the investigations have found, there is a third variant that was identified in Brazil a little bit after these ones. Now, we won't talk about this variant in this video, mainly because there's not a lot of data yet about it. But in general, keep in mind that the scientists have noticed that the South African version and the Brazilian version are very similar. So they think that the Brazilian variant of SARS-CoV-2 would behave a lot like the South African version. Of course, this can change as more research is done, but just keep that in mind. Before we share with you the scientific research and details about whether our immune system will be able to fight just as well against the original version of the virus as it will against these new strains, especially after we've been vaccinated, we need to just backtrack a little bit. How do we build immunity? So there's two major ways generally to build immunity. One way is to be exposed to the virus. And if you've successfully fought off the virus, then you will have built immunity. So an ability to fight off the virus later on if you were to be exposed to the virus again. So that's one way to build immunity. A second way to build immunity is to be vaccinated. So the vaccine would give you the immunity to fight off the infection by the virus down the road. And the great advantage of the vaccines is that they prevent you from getting the disease. So although you will build immunity, you will not suffer the ill effects of the disease of COVID-19. So that's in general the way to build immunity. So to the details of the experiments that were done, in order to determine whether that immunity will protect you not just against the original virus, but also against the new strains of the virus. What scientists did is they took blood samples from individuals that had either been exposed to virus or that were vaccinated. And in this case, individuals were either vaccinated with the Pfizer mRNA vaccine or the Moderna mRNA vaccine, since that's the ones that's being used more broadly currently. So they took blood samples from these individuals. And what they measured out of these blood samples is the ability of the antibodies in the blood. So the antibodies being one of the many components of the immune response in the immune system. So they measured the ability of these antibodies to block the strain's ability to infect new cells. So in the context of the UK variant, they showed that antibodies from any of these individuals was able to block the ability of the UK variant from infecting new cells. Great news. In the context of the South African variant, the antibodies, they blocked the ability of the South African variant from infecting cells, but they had a little bit of a lesser activity. Granted, it still was able to block the infection, but they have diminished ability to do so. So what does that mean? Well, if you take the experiment into context, meaning these experiments were done in the isolation of a laboratory, and they measured only one of the components of the immune system, the antibody component of the immune system, but there are many other components of the immune system that are not being taken into consideration unless you start questioning or asking these questions, answering these questions in the body, in the human being. So what this means is, or what scientists expect, and I think most pharmaceutical companies expect, is that although the immunity that you've built is not quite as good as blocking the infectivity of the South African variant, is still able to block it. And in the context of the whole body, what is expected is that the rest of the components of the immune response will be able to help fight off that virus. And on a side note, what I can tell you is one of the things that they also looked in these studies is the ability of the antibodies in these individuals to bind to the original version of the virus, to the UK version of the virus, and to the South African version of the virus. And in all cases, the antibodies were able to bind to every single one of the viruses, the original and the new variants. Maybe to the South African variant a little bit less. But the reason why that's important is because the ability to recruit other components of the immune response, in addition to the antibodies, the ability to recruit other immune response components is dependent on the antibodies, my body's ability, or my antibodies' ability to be able to bind to the virus. So if they bind to all the viruses, then there's a high likelihood that they will be able to activate other components of the immune system, like the T cells, build memory cells, macrophages, things like that. So the expectation is that these vaccines will be able to protect you against the new variants of SARS-CoV-2. Now, what does this mean long term? Since there was a little bit of a reduction in blocking the South African version, does it mean that the immunity against that specific strain may be a little bit shorter lived? We know that the ability, or your immune's ability to fight the original version of the virus lasts about 8 months and counting, because we're still sort of monitoring that. So the question would be, well, will that length of the immunity be a little bit shorter lived in the context of one of these variants, specifically the South African variant? Well, currently we don't know, but we will as we continue to monitor these studies and that the researchers are doing. Now, one potential solution, even if you have a shorter lived immunity, is to actually create a booster shot. So something that companies like Moderna, and we're sure that Pfizer is also doing, are already creating. So they're creating booster shots that they can give you that would boost your current immune response to the original virus. And within it, you will also engineer an ability to build also an immune response to specifically the new variants of the virus. So this is a fantastic way of sort of dealing with these new variants, especially fantastic because now we know we can make these vaccines fast and quickly, and they're extremely efficient. So that's in general the idea of these studies and how maybe the future of the vaccine world will be in context of COVID-19. So what are the take-home messages from this video? Well, first of all, don't be scared of mutations. I know we all have an aversion to mutations from our sci-fi movies and novels, but mutations happen all the time in the context of viruses. And remember that most of these mutations have absolutely no effect on the virus. It doesn't really matter to the virus and to us, obviously. However, having said that, sometimes some of these mutations can make the virus much more efficient at infecting us or spreading throughout the population. And scientists know that. That's why they're constantly monitoring the evolution of the virus and making sure they identify new mutations. And when they do identify new mutations, they spend a tremendous amount of work figuring out if those mutations are actually making the virus more transmissible and making it a more aggressive virus. So we'll know, they will know. Also, what they're monitoring is whether our immune response, especially the immunity that the vaccine has given us, whether that immunity allows us to not just fight the original version of the virus, but will allow us to fight the new strains of the virus. So again, a tremendous amount of work and effort by the scientific community monitoring all these scientific events, all these biological changes, and adapting to them. On that note, we have an amazing technology. This mRNA vaccine technology has allowed us to make vaccines at a super fast speed with a high efficacy. And because of that, it will allow the scientific community, it's already allowing the scientific community to make changes or adaptations to the vaccines, so the vaccines can better protect us against the original strains of the virus, as well as any new strains of the virus. Again, a fantastic amount of information, super exciting science going on right now. Hopefully you enjoyed this video. If you did, please give us a thumbs up. If you didn't, we'll take the thumbs down. In general, the goal with our videos is for us to share as much of the scientific data as we can with you, so you can sort of make your own decisions in general about your health and your day-to-day life. If you know anybody who might be interested in this video, of course, please share with them this video and encourage them to subscribe to our channel. And of course, we encourage you to subscribe to the channel too. As usual, if you have any questions or any comments about this video or any other topic, don't hesitate, put a comment in the comment section and we'll be able to address your questions and maybe even create new videos just for you. So thank you for watching and we'll see you in the next video. Bye-bye.